So far, we went over one example. We saw the relation between GDP as free variable and CO2 emission as Y dependent on X. And we saw that, hey, we have a strong positive linear correlation between them because of R. The interpretation was, as the gross domestic product increases, the carbon dioxide emissions tend to increase as well. Now let us talk about regression lines. After checking to see that the linear correlation between two variables is significant, the next step is to check to see how we can calculate the equation of the line that best models the data. This line is called regression line. Its equation can be used to predict the value of y for given value of x. Although many lines can be drawn through a set of points, a regression line is determined by specific criteria. Consider the scatter plot and the line shown below. For each data point, d sub I represents the difference between the observed y value and the predicted y value. So d sub I represent the difference between the observed y value and the predicted y value. What's the difference between them? Remember that when you have some points in the plane, they might not be on the exact same line, but our goal is to find a line that best represents the data. You're going to end up with some residuals. The residuals, or DIs, are the difference between the observed value and predicted value. DIs can be positive, negative, or zero. When the point is above the line, DI is positive. When the point is below the line, DI is negative. And if it's exactly the same as your value, DI is equal to zero. So here you have the observed value, Y, and the predicted value, Y. The difference between them is denoted by D3. Why? Because it's the third point. In this case, you have the observed value down here and the predicted value on the line here. The difference between them is DI. Remember that our goal is to make this quantity to be as minimum as possible. The sum of squares of the residuals need to be in its minimum value. A regression line, also called a line of best fit, is the line for which the sum of the squares of the residuals is minimum. In algebra, you learn that you can write an equation of a line by finding its slope, m, and y-intercept, b. And remember that the equation was mx plus b. For example, here you have a line, increasing line, with equation y equals to 2x plus 1. M, or rise, over run, is 2 divided by 1, which is 2. The intercept, when you set x equal to 0, the intercept, y-intercept, is equal to 1, which is this point here. The slope of a line is the ratio of its rise over run, and the y-intercept is the value of the point at which the line crosses y-axis, this value here. So to find the y-intercept, we just set x equal to 0. So in this case, as you can see, the y-intercept is 1. In algebra, you just use 2 points to graph a line or come up with the equation of the line. But when it comes to statistics, we need a bunch of lines and try our best to make sure the squares of the residuals after adding them together is minimum. So the sum of di squared are minimum. This is your goal in statistics. The equation of a regression line for an independent variable x and a dependent variable y is denoted by y hat equals to mx plus b. Y hat is the predicted y value for a given x value. The slope m and the y-intercept b can be calculated this way. Very good. So m is n times the summation of x times y minus the summation of x times the summation of y's divided by n times the summation of x squared minus the summation of x to the second power. And then to find a y-intercept, b is equal to y bar minus m times x bar. But y bar is basically the average of y values minus m. X bar is the average of x values. Y bar is the mean of the y values in the data set, and x bar is the mean of the x values in the data set. And n is the number of pairs of data. The regression line always passes through the point of average of x values and average of y values. So let's go over one example together, finding the equation of a regression line. Find the equation of regression line for the gross domestic products and the carbon dioxide emissions data. So this is the data that we have. We visualize this data. We found the correlation coefficient for this data. Now our goal is to find the regression line for this data set. What are we going to do? We're going to follow the formula. M is equal to n times the summation of xy minus the summation of x times the summation of y divided by n, the summation of x squared minus the summation of x to the second power. These are the calculations that we did before. So we just punch them into the calculator and we find m to be positive. M is 166.900. 438. The y-intercept formula was b is equal to y bar minus m times x bar. Y bar, you basically add all of these numbers together and divide it by 10 minus m, which is calculated up here, times x bar, which is adding all of these numbers together, divided by 10. So y-intercept is about 115.725. Now we can visualize this and write the equation of regression line. The scatter plot has some data, but this line that passes through these points in its best case, that minimizes the summation of di squared, has slope 166.900x. This is your slope of the line plus the y-intercept, the value that the line crosses y-axis. So that's how we calculate the equation of regression line y hat and visualize this on the right-hand side.